Hi, this is Jeff Heaton. I teach a class at Washington University on applications of deep neural networks. Some of you have been following along with these videos as I release them. Some of you perhaps not. If you're not, that's a good time to subscribe to the channel. However, there's a lot of new and exciting things going on in the underlying subject matter that I have. So the TensorFlow and Keras are the two things that I base this class primarily upon. TensorFlow 2.0 is just about to come out, and we're right at the end of the spring semester for 2019. So I've got the whole summer to essentially reboot and rebuild the class for the breaking changes that came from that, but also just look at what we're really going to cover. That's where I'd like help from you. What would you be interested in as far as deep learning? Let me give you some of the topics that I am currently considering for the next time around. Nothing is set in stone. This is just an outline at this point. So the discussion area, the comments below would be a perfect area to give me some ideas, and I'll definitely respond. I'm trying to set this course up so that we really cover what makes neural networks unique and not just treat them as another type of machine learning model that you might swap out a support vector machine for. What's exciting about deep neural networks is the fact that they can take almost anything as input and have almost anything as output. Output can be images, output can be audio or text, input can be any of those things as well. So the first two modules, there's 14 modules in all, each will have 5 10-minute or so videos that go along with them, 10 to 15 minutes. The first two modules, and this corresponds to the 14 weeks that Washington University typically uses for a course, will cover Python. Not too much there, but I cover really Python with an orientation towards using pandas and getting things set up to work with Keras and TensorFlow. We also talk about how to read images and process images. So all the fundamentals of Python that you need for deep learning. Then we get into a review of TensorFlow and neural networks, how to train for tabular data. This is where you're seeing neural networks just like you would use a support vector machine or an XGBoost or LightGBM. This is doing traditional data sets that are not images and other things. Neural networks won't necessarily outperform other methods in this way, but we'll see how some of the auto feature engineering capabilities of neural networks help out. Talk about regularization and dropout to avoid overfitting. Recurrent neural networks. Now, I decreased the amount of coverage I give to this because LSTMs are great and all, but they seem to be losing mind share to some of the new CNN-based, convolution neural network-based approaches for temporal data. We'll get into CNNs for sure, CNNs for computer vision. I always have a Kaggle in class competition, so we talk about Kaggle competitions because these are great sources of data sets for this type of class. We'll do convolutions for time series, and we'll really see some of the advantages that they have over the traditional recurrent neural networks that were used for this. Now, in this course, I show how to use Google Colab so that the students have access to a GPU. Because this semester, I'm really requiring a GPU for this. So we'll talk about how to use it in Colab, and you guys have been asking me for tutorial videos on GPUs, so that is coming, so definitely subscribe. Transfer learning is very important because we can use these weights and neural networks that tech companies have produced for us on large computer arrays that have more GPUs than we have access to. So we'll see how we can import that knowledge into our neural networks. Natural language processing, we'll use convolution neural networks for that and basically see what's available in the deep learning area for NLP. GANs have really come on strong. I didn't have these in my class previously. We'll see how to use them for image generation and other things. I want to also take them out of just the context of image generation, show how you can generate some traditional business data with that. Reinforcement learning has done amazing things with video games and teaching the computer how to carry out tasks. We're going to include that in this semester. Look at some of the traditional gaming applications as well as more traditional business use. And then the last class, I cover a variety of just other techniques, some in the area of feature encoding, like autoencoders, auto-denoising encoders, and other things like that. And that's the course. What are your ideas? Leave those in the comments. And throughout this summer, I'm going to be releasing quite a few videos as I put this whole thing together. So please subscribe to the channel and click the bell so that you're notified of any changes as they come about. Thank you very much.